Thank you. So my talk is going to have two different parts. The first part is really about citizen science, because I have been the convener of a number of citizen science sessions at the EGU, for example, and many of them are a total failure. And they are a total failure because many people see citizen science project as a technical issue. And it is not a technical issue. It is really about what can you offer to the citizens. And in the second part of the talk, I will then present a bit more what we can do. So basically, when you have, I have called it the first commandment for the citizen science project because I think many people miss the point. When you want to start a citizen science project, you have first to understand what can be the motivation for the participant. If you don't offer them anything, do not expect them to join the project. And I think it is very, very, very important to understand. The second point is what are the people, what is the community you are trying to engage with? And depending on the type of community, you have to have a very different type of strategy. One of the most successful citizen science projects is the eBird project. They are absolutely incredibly successful. But this is very specific because they engage with the community which has been existing, at least in the UK, for at least 2 centuries, the birders. So basically, you connect with an existing community and you provide them tools, and you get a huge success. And when I say huge success, they can collect 10 million geolocated peaks a month, so which is absolutely huge. But when you look at how many people participate, it's pretty limited. They just have a huge level of engagement with this. Concerning the citizen amateur seismologists, I think they are not so numerous, because if we look at the people, very often they are seismologists on their own, and so far we have not really managed to have identified this community. And I think this is something, one of the big advantages of Raspberry Shake, because when you have people willing to spend 300 euros to buy an instrument, then you can believe they are interested in seismology. But as you see, they may be in their thousands worldwide, so it's not a huge community. And I think one of the big advantages of Raspberry Shake has been to try to identify this community. We have been discussing for the last 18 months with Kate Wenshan and Wenzhong Liang in Taiwan, because there's been made they had a very, very ambitious citizen school seismology project. And Kate sometimes is a bit disappointed because people are not as motivated as she thought they would be. So now we have also discussed, and they have been developing, it is currently being tested, they have been developing a web tool to basically play with data, locate earthquake, so you pick, you locate, etc., etc. And the idea is to go complementary with Raspberry Shake. It is just to make an advertisement of this on the social network and to see who is interested. So at the beginning, you don't have to register. You just play with the data. If you want to get more ID, then you have to register, and then we can create a community of citizen seismologists and work with them. So I think this part is very important, and really, this is still being tested. I know that they've also now approached IRIS to be in link with them, and I think it's a very great development to understand how we can do. So concerning LastQuake, so what we do is not a citizen science project per se. What we are trying to engage with are eyewitnesses, and eyewitnesses only exist once the earthquake has occurred. So it is basically a spontaneously emerging ephemeral community. So it's totally different. And how do I identify them? Then it's a different story. They identify us. When there's an earthquake, some people go make a Google search, basically. And making a Google search, a number of them hit our website. So this is the traffic on our website following a failed earthquakes. So when you detect a large traffic surge, you know an earthquake has been felt. You just have to look where the IP come from, the geographical origin of the IP, and then you know where the earthquake is before seismometers in the vast majority have reported it. Typically, we detect the majority of them below 1 minute now. So how do we engage? So people identify us. How do we engage? It's simple. We just put this type of message on our website, on the app, which is just to say, hey guys, it seems we have abnormal activity at the moment, and that's enough. You put this, and people start reporting the earthquake and providing felt reports. So this is how it works in our case. What we have been advocating for a number of years now is that, because 30 years ago, when I was still a student, we knew an earthquake was felt because the phones were ringing in the lab. Phones are not ringing anymore, at least in Europe, as far as I know. But basically, it's the internet which played the role of the digital nervous system of our planet. This is the website traffic on EMSC during a couple of weeks. This is the day and night variations. Every time you have a surge, you have a felt earthquake. And of course, the amplitude is not only related to the magnitude, because the amplitude is related to the number of people who felt the earthquake. And if the earthquake is felt below city, you will have a larger amplitude for the same magnitude. So it is really about like hazard and risk. What you look here is that the reaction of the people. And people are real-time sensors. This is an earthquake in 2016 in Oklahoma, so some of them know very well about this. This is the earthquake, this is the time, these are the PNS waves, and this is just, the red dots are just the IP location for which we observe the statistically significant increase of traffic. So you see it follows the propagation of the waves. We have a paper on SRL, and we show that by just retro-propagating the hit time on our website, you locate the earthquake. So people are real-time sensors.
This is on the EMSC website?
Yeah.
Or the USGS website?
No, that's our website. No. And, oops. Here it is. So basically, if I want to summarize what we do, is that there are two ways to detect an earthquake. The classical way, which is by seismic sensors, you have, and they provide the earthquake location and magnitude, and you have when people feel the earthquake. And then they have an activity on social media, and they find us. They find us, we collect data, so what we call the indirect data, so all the activity on social media. We merge them to improve our product, and it attracts more people. So basically, it's a positive digital feedback loop, sorry. And it goes extremely fast. So basically what I want to explain is that when you want to engage, you have to understand the community and you have to understand what the people do during an earthquake. So one thing which was done by Paul Earle at USGS was looking at Twitter. In countries where Twitter is popular, and it's far to be everywhere in the world, people tweet. So if you have an earthquake in California, people will say, oh my God, earthquake. So you just have to count the number of tweets containing the keyword earthquake, and you have this type of curves. So when you have a large increase, so it's another way to look at the human reaction, you know something happened. And if you're lucky enough, and it is a lucky case here, you can look at the geolocated tweets which contain peaks, and you can have data about the damage of the earthquake, about the impact of the earthquake. What we have been doing over the last couple of years is now looking at the people launching our app. So we have a smartphone app that I will present, and when people feel the earthquake, they launch the app. So it's not the website traffic, it's how many people launch the app. Here we are down to seconds. So people, and I can show you if you're interested, people react to the shaking, and basically within 10 seconds of the shaking, you have the first people launching the app. So this is extremely fast. You know, the triggers here is basically in 20 seconds, and you have a nice location. So here, if you can launch the video, please. I don't know the name. Gary? Yep, here it is. So I like this one because there were two felt earthquakes, 1 minute apart. The full duration of the video is about 10 minutes. One was in Tajikistan, 7.2, and one was here in Chile, 5.5, only felt locally, and here felt up to the Emirates. These are the location of the app launches. This is me launching the app. And basically, you see, you can map the felt area in real time. And I will show you what happened once we have the earthquake location and magnitude, we send a notification, so an alert to everybody, and then you see the effect and you will see all the map lighting up. So basically, again, you go faster and faster just by looking how the people react. And I like also those examples, but I have many others because it works even in countries like Afghanistan. So it's not restricted to the richer country. then we have launched now the notification, and so people react to the alert. So what is our app? Our app is very simple, and again, we have been very lucky because it was not developed by a seismologist. We have the communication officer, and we wanted as seismologists to put a lot of information. And she was always saying, no, nobody's interested in that. Forget about it. No, nobody cares, etc., etc. So we went to a very, very simple color code. We only report felt and damaging earthquakes here. You have the full list if you are interested. Felt and damaging earthquakes are no more than a few % of the earthquakes we locate, so they are very small proportion. We have detected felt earthquakes down to 0.9 in magnitude, so it can be very, very small in magnitude. People can share also their pics, their comments, and share them also on their own Twitter and Facebook account. And we have replaced the traditional online questionnaires by 12 cartoons depicting different shaking level. We have basically a global coverage now. China is a problem because they don't have access to the stores, but we have a global coverage. And again, second point that you have to understand, even if you have the best app in the world, today it may not be found, simply because there are 1 billion apps in the stores, and the top one in the rank are the ones which have the large number of downloads. So if you start today, you are unlikely to be found. 95% of the new apps are not downloaded today. So don't make an app and just think people will find it. This is not the case. So you have different type of strategy, and MyShake is a good illustration of one strategy. If you manage to have a large media coverage, look at the rapidity of your download. So then people will find it, because then after this, you are at the top rank. But realize when you go now on TV, you have a lot of advertisement for apps, simply because you need to have people finding out. How do we do in our case? It is not the app alone. It is a multi-component information system which works on social media, so Twitter, but also now Telegram. And we publish on Twitter, so in this case, so we have detected a traffic surge, so we publish everywhere there is a potentially felt earthquake in Italy in this case. We put the keyword in Italian on Twitter because the people are not looking for earthquakes if they're in Italian. And here we invite them to go to our website. And from the website, we invite them to download the app. So an app on its own is not sufficient. You really need to have a way for the people to find it. And the rapidity of downloads is quite amazing. I take this earthquake, this 4 hours period in Italy last January, so a year ago. Excuse me. There were some 4 magnitude 5 earthquakes, and these are the number of downloads during this 4 hours window. So it is extremely fast. You have also to realize that people are as fast to delete the app too. So that's really something that you cannot take as granted, and it changes extremely rapidly. So how fast are we able to collect the felt reports? This is an example of one of these 4 earthquakes last year. So I will just show the number of reports here and the time here from the earthquake. So in 1 minute, so it goes extremely fast. So these are the final. So last year I was very happy to present this because I consider this very fast, but it goes much faster now. Now we are down to 30 seconds window, and these are, so here we are only 3 minutes. 3 minutes after the quake, and you get 300 basically felt reports. So this is absolutely amazingly fast, how fast. As far, again, as you try to listen to the user needs, you can have dramatic performances. And again, it works everywhere. We collect approximately 100,000 felt reports a year. As you see, we cover, except China again, but we cover every active region in the world. A year ago, half of these reports were collected in 10 minutes. We are now closer to 5 minutes. So it's keep accelerating over and over. Another point which is important to understand, that an app alone does not make all the job. I take again the same example from this earthquake in Italy. I look at different time window from the earthquake occurrence, and I look how many people do I reach with the app, with our website for mobile devices, with our classical website. So as you see, with the app, you don't reach so many people. In 30 minutes, we reached 2,000 people from Italy after this earthquake. If you compare with the website, we reached 16,000. So for broadcasting information, the app is not the best tool. But when you look for crowdsourcing, how many reports we collect through these different ones, then the app is by far the best instrument. So again, it is not having a single system which satisfies everything. You have really to think about to have a multi-component information system. And fastness matter. I always take the example of an earthquake which was felt in this country a few years ago in Market Rasen. No, it was not this one. It was Rutland. It was in the middle of the night. Nobody in the UK has ever heard about EMSC because there is no earthquake, so there is absolutely nobody. It was in the middle of the night. We detected a traffic surge. We were the first one to report the earthquake. We collected what was at the time a large number of felt reports, 700 felt reports in 30 minutes in the middle of the night, simply because people find you. So fastness does matter. These are, for example, a recent earthquake in Indonesia. We get 500,000 views for an earthquake on the other side of the planet. So really, fastness matter. People are looking for information in real time, so if you provide it in real time, you will get visibility. So this is a video showing the app launches. This is again the earthquake here. And in orange, that's when the people launch the app before we send the notification. And in purple, that's once we have the location and magnitude and we have sent the notification. So basically, in purple, that's people reacting to the alert rather than to the shaking. But several things are of interest. You know that we don't get much launches. The black dots are the distribution of our users. We don't get much launches in the epicentral region. And we had a recent paper in SRL, and we called it the donut effect. So we have made statistics on the felt reports and on the app launches. So what happened? This is a very schematic map view. And how do you crowdsource information depending on the level of shaking? What we have shown is that if the shaking is not violent, so when people are not scared, you collect information instantaneously. When you reach approximately 5 and above, up to 7, so when objects start falling around, people first go to security. So you don't have any information during 10 to 20 minutes. And in the damaging area, you don't get any information. That's as simple as this. So basically, the lack of information is an information on its own. And it's quite obvious if the next building has collapsed, you're not going to say, oh, is it an earthquake? No, you know it is an earthquake. And you have other priorities to do this. So this was a statistical study, and we applied for the first damaging earthquake after the study. It was the Iran earthquake on the border at the border with Iraq. So the way we present the data here is the time from the earthquake occurrence, epicentral distances. The black dots are the app launches, and the color dots are the felt reports, so the colors depending on the level of intensity. And it's quite amazing because it follows exactly the path which was observed statistically. During the first 20 minutes, we have only one launch in the first 80 kilometers. So when the shaking was violent, and you see this part shrinking, but we have absolutely no information within the first 40 kilometers where the damage lie. So now we are also working on different aspects, is that if we have users here, we do send them a notification, and we want to exploit the metadata of the notification to know whether it was received, and when it is not received, whether it was due to cell tower being broken, what are the reasons. So that's something which is currently in place. We're also playing with something which I like it very much. It is to estimate the magnitude independently of any seismic data. The surface of the felt area for crustal earthquake is linked to the magnitude. Obviously, a local small magnitude earthquake is only felt locally. So when we detect a traffic surge, we look at when the traffic surge started, and we estimate the surface area of the cluster defined by the app launches. And so we don't know. The zero is just the beginning of the surge. We don't know where the earthquake is. We don't know the origin time of the earthquake. And we look at the temporal variation of the felt area. For a small magnitude earthquake, everybody has felt the earthquake at the same time, so you don't have time evolution, and it is a logarithm scale, so the surface area is small. When you have magnitude 5, then it keeps increasing because there is a propagation effect. And when you have magnitude 7, when you have to wait 3 minutes before the last one feeling the earthquake. So you can basically estimate the magnitude. At least you can always put a lower bound of the magnitude in real time just by looking at this. And you know very rapidly if it is a magnitude 2 or above. So the first damaging earthquake since the launch of the app was the Nepal earthquake, and we were dramatically successful there. And that's when really when we understood the importance of satisfying the needs of the people, because we are very surprised by the number of downloads. And 6 weeks after the earthquake, we made an online survey of from our users in Nepal and asked them how did they find our app. There was no media coverage at all. It was just because we are the only app to provide the alert on felt earthquakes, which is what the people want, what eyewitnesses want. And we asked the people, what do you want as an improvement? And again, they're not interested in earthquakes. What they ask us is, tell us what we should do after an earthquake. That's all. So we have included now do's and don'ts. We use the same visual communication than for the felt reports collection, because as you see, when you go in multi-language, you can have some translation issues. And also because visual communication is much more effective when people are anxious or under stress. People under stress may read only one of the 3 words. So if you send them a text, they will only pick up, because of the stress, pick up a couple of words and try to make sense of it. It's not, they do not realize it, but it's just the way our brain works during stress. So visual communication is much easier. So what we do basically in case of a strong earthquake, once we have the earthquake magnitude and location, so a few minutes after the quake, we look at who are our users we went through violent shaking, and they get a specific notification where they can send, so they have a safety check, so they can send SMS to their loved ones to say they're in security, or check the safety tips. So it's important to understand the safety tips are arriving after the shaking, not during the shaking. And we're happy that we don't have to do to give advices what you should do during the shaking, because the drop, cover, and hold may not work everywhere. You have to be sure that your building are not going to collapse to go below the table, which is not everywhere the case. So we have identified key messages. Again, we have made some drawing. We submitted online to our users. We get 800 answers from 76 countries. We made some modification. It cannot be perfect because, for example, we used this fix, which for the majority of us makes sense. We use it because it is part of an ISO norm. But in Asia, it is far from being easy to understand. So you always have to understand that it is difficult. But we had rate, before the latest modification, we had rate up to, the lowest was 85% of understanding, which is not bad. And again, how do you understand that you satisfy the needs just at the way the people rank the app? So 2 things. If you make an app, you have to be sure it works. Here, so this is the cumulative rating of our app, time evolution. Here, we had a bug during an evening, and it sent a number of false notifications. You get killed instantaneously on the rating. So that's the truth. It's a matter of minutes. You get it wrong, you are dead. We put the safety tips here. This is the only modification, safety tip, safety check here. And you see, since that, the rating has kept increasing. So it is not approved, but we are pretty confident that we satisfy the needs of our users. So basically, apps, we strongly believe that they can contribute to risk reduction. They can contribute to risk reduction by 2 different ways. First, because we can improve situation awareness through crowdsourcing information extremely rapidly. We are well below the hour now. We can limit inappropriate behaviors. And there is one thing which is important. It is also you always have aftershocks after the earthquake. So if you can provide this information right after the first earthquake, the main shock, then it's still valuable. It is also visual communication, I think, is absolutely of paramount importance if you want to have a global service. We have tried to have a questionnaire in various languages. It just doesn't work. That's just too complicated. And even if we don't manage to do this, sociologists explain us that the best medication against anxiety is information. So during crisis, you need to provide information. So even if it is the only effect we have, I think it's good considering the cost of this type of developments. In our case, offering timely information is absolutely key to engage with eyewitnesses. And I insist our target are not seismologists, they are eyewitnesses because they are the ones who have the information of what's going on the ground. Don't think you are going to change the way people behave during a crisis. People use the same tools that they are used to do. So you have to understand their behavior, and you have basically to fit in their pre-existing behavior. You are not going to change the way the people behave. And again, an app, except if you have, but you must have a strategy to make sure that your app is found. Otherwise, it will stand alone in the stores and whatever the quality of it. So that's our last stuff. I will not mention, I will discuss it, but I will just, this is the density of the launches of our app for two years period. So it covers the majority of the seismically active regions. But you see also, in Northern Europe, we are quite also active. There are quite a lot of activity in Northern Europe. I will not go in details here, but I think there is also something interesting is that what you can map here is probably the diaspora of the people. For example, when you have an earthquake here, you have a lot of launches from the UK. So I think it's interesting also what I love in all these developments is that you see a lot of things in terms of human behavior. So that's really joining citizen society behaviors and science. Thank you.
But this is all about what has happened. What about predicting? Can you get anywhere near?
No. So this is the answer is short. Yeah. But I think, no, but more seriously about your questions. Again, we are not targeting citizen seismologists. We are targeting eyewitnesses. It's just a different world. Citizen seismologists are people who are interested by the topic. Eyewitnesses are, in the vast majority, not interested in the topic of earthquakes. So this is why you have to have a different strategy. And I think that's what Kate Wang-Chen in Taiwan is doing is great. What Raspberry Shake offers today is great because they offer a way first to identify these amateur seismologists around the world, so to create a community and to see what they can bring in science. If you look at the performances of this Raspberry Shake, it has interest to lower the magnitude of completeness of the catalogs, or for discrimination of quarry blasts, if you put one of them not far away from a quarry to make sure that it is well on the quarry, etc., etc. So there is, and I think we are living in a very specific moment because for the first time, up to now, very often the school initiatives were on the separate instruments, and there was little interest, scientific interest for the data. Today, there is a scientific interest for the data, and the equipment cost is so low that we can envisage to have massive equipment, and people can play with the data, they can learn what are the effects of uncertainty in picking on the location accuracy, etc. So there are a lot of stuff which can be done easily and at very little cost now, and using existing software, which I think is really a great change now.
Can I add to the comment? I mean, so just to be clear, while clearly we cannot predict earthquakes, what we can do is warn an earthquake shaking. And so So that's different. So
Yep.
we seismologists would typically say prediction means as in there's going to be an earthquake next week. We cannot do that. But what we can do is provide a warning before the shaking starts of a period of seconds, tens of seconds. And so when it comes to actually delivering people something that they want, I would say that the best thing that we can deliver to people is a warning that the shaking's coming.
Yep.
And so making that connection with citizen scientists and giving them an opportunity to contribute to that, I think is a very powerful combination. And that's what the Earthquake Network is doing.
Yep.
And that's what we would like to do with MyShape. We're not doing it yet, but I think that's how you bring these points that Remy's making to really kind of expand the capabilities of the citizen scientists.
And to complete what Richard just said, is that if we look, we have never tried in our case to optimize the rapidity of triggers. We are down now in the best case around 15 seconds. If we optimize, and basically it is totally linked with the number of users we have in the area. So we can probably go down to the 10 seconds trigger. And in this case, we are going also in type of a crowdsourced earthquake early warning at very little cost, so which is one of the big benefits of this type of developments regarding these aspects. It is not a priority at the moment. At the moment, it's really about collecting a lot of information from the people, and again, just to give you the idea, I think it provides new field for research. There has been a number of felt earthquakes below the city of Skopje in Macedonia, former Republic of Macedonia, to be accurate. Otherwise, I will get in trouble with our Greek colleague. So there has been a number of small magnitude felt earthquakes. We have collected something like 15,000 felt reports in circles of 5 kilometers radius. I'm quite convinced that they bring some information. They convey some information about the site amplification. So there are all type of information that can be done with this type of data. And that's why I think it's absolutely essential that we bridge not having citizen science project or school project on their side and science on the other. I think there is a mutual benefit, and we have to work together because there are a lot of data that a lot of things which can be done by working together on this.
Whenever I hear about statistic data collection, and I'm guessing you have a large amount of data to work with, have you ever considered using machine learning, or are you now using machine?
No.
Specifically for the magnitude prediction, because I can imagine machine learning would be a great tool to find correlations between the parameters that could really improve the magnitude prediction.
So no. The short answer is no. We have no machine learning. We are a small group, so we are really focusing on and we provide operational services. So that's our main goal. So we spend a lot of time just to maintain and make the required evolution of the system. Concerning the magnitude estimate, there are existing relationship between the surface area and the magnitude. So it depends on the local attenuation. And basically, the point is not to say it is a 5.2 earthquake. It is really about being able to say extremely rapidly it is a small local earthquake, or it is a moderate earthquake, or it is a large earthquake. But we are working at the moment with mathematicians in the Descartes University in Paris, and because we cannot have all the competencies on this, so they play with our data, and we hope they will provide us with a better solution than what we are able to do.